Hello everyone. Right, this is a lesson on sequences now. So, sequences. Okay. Now, I have a sequence. It's just a row of numbers like 2, 4, 6, 8, 10. And what's the next number in the sequence? Well, we know it's going to be 12, don't we? So, that's basically what a sequence is, and they're all different kinds of sequences. So we'll first look at the triangular numbers, and it makes the shape of a triangle. So the first number in a triangular sequence is 1. The second, see we made a triangle there, is the total number of dots is 3. And then we add another 3 to make 6. Add another 4 to make 10. Another 5 to make 15, and so on and so forth. So that basically is what a triangular sequence is. Right, next one is this one. It's called Fibonacci. I think it might have two eyes. Fibonacci, an old Italian mathematician from way back when in the 15th century. So Fibonacci sequences are like this. They do not have to start with these two numbers. I will give another example. With Fibonacci sequence, to find the next number, you add the two previous ones. So we've only got 2, so the next number will be 1 and 2 make 3. 2 and 3 are 5, 3 and 5 are 8, 5 and 8 are 13, and 8 and 13 are 21, a Fibonacci sequence. So to find the next number in the sequence, we just add these two, which will be 34. So what happens if we have a Fibonacci sequence that starts like this? 3 and 3 are 6, 3 and 6 are 9, 6 and 9 are 15, 15 and 9 are 24, 24 and 15 are 39. So a Fibonacci sequence. And you might have to find a missing number in the sequence or a sequence at the end. If we start with minus 5 and minus 10. So minus 5 and minus 10 are minus 15, minus 25, minus 40, and minus 65. And what if we start with minus 5 and 5? Minus 5 and 5 are 0, 5 is 5, 0 and 5 are 5, 5 and 5 are 10, 5 and 10 are 15, and 15 and that. So it sort of goes up and down a bit, so there's 25. Fibonacci sequence. Perfect. Alright. Next kind of sequence is a geometric. And this is where we multiply each number by the same thing each time. So you may have a sequence of 8, 80, 800, 8,000, and 80,000. So we're multiplying each number by the same thing to get the next one in the sequence, and this would be seen as the rule. What rule are we applying to this sequence? And the rule is multiply by 10. We can have a rule of multiply by 3, and we could say start with 5, and then it would be 15, and then it would be 45, and then 135, and so on and so forth. We can have a rule that multiplies by a half. So start with 100, and we've got 50, and 25, and 12.5, and 6.25. We can have a rule that multiplies by minus 2. Let's start with 4. 4 times minus 2 is minus 8. Minus 2 times minus 8 is plus 16. Minus 32 plus 64. So we go plus minus, and there's the rules for a geometric sequence. The one that is much more involved, and you get much more questions on it, is an arithmetic sequence. Yeah, and this time you add the same thing. Add the same thing every time. For example, 3, 5, 7, 9, 11, 13. And the rule here is add 2. Alright. Now, all these arithmetic ones that I'm going to present to you today are all linear. Means there's no squares involved. There's no squares, no crazy squares. And what the rule is really can be seen as the nth term. So we're going to make a little algebra expression that we can use to find any number anywhere in the sequence. If we know it's adding 2 every time, we can find the 100th number in the sequence by using what we call the nth term. So what we'll do with this set of numbers, 3, 5, 7, 9, 11 and 13, let's just move this down a little bit for you, so that we've got, whoops, did I catch all of that? Yeah, okay. So we're going to do at the top the n number. Now this is the number in the sequence. So first, second, third, fourth, fifth and sixth. So we have the n number. Then we find the rule. So this is add 2, add 2, add 2, add 2 and add 2. Now the 2 becomes our n number. So we have 2n. Now we need to find out what the value of the 2n is. So let's come with a different color. So we do 2 times the n number, these red ones at the top. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 8, 10 and 12. Now this is what we know the value of 2n to be, but it isn't the same as the numbers in our sequence. So we have to subtract what we know from the sequence numbers. So 3 minus 2 is 1, 5 minus 4 is 1, 1, 1, 1, 1. Yeah, so we have to add 1 to our n number to find out the nth term. And this will be 2n plus 1. So this nth term will now enable us to find any number in the sequence. So if we want to find the 7th number in the sequence, we know it's going to be 15 because we're just adding 2, but we'll use this, yeah? So we go 2 times the sequence number, the n number, 7, put that in brackets to make it tidy, plus the 1, yeah, plus this one down here. So 2 7s are 14 plus 1 equals 15. So our next number in the sequence is 15. Now, if we wanted to find, wanted to find the 50th number in the sequence, yeah, we'd go 2 times 50 plus 1 is equal to 101. 101 will be the 50th number in the sequence. So we can find anything. Yeah, so let's have another go at a different sequence, because we can get some negatives and we can get some positives. So let's do this. So the n number there is 1, 2, 3, 4. We only need to do 4. And we'll do the numbers in the sequence, which are 6. No. Let's put more interest in that. 7, 15. Just let me find an example where I've got. So we won't use the 6, we'll use the number 7, because lucky for some. So we go 7, 13, 19, and 25. Right, so let's find out what the n number is, yeah? So 6, 6, 6. So we're adding 6 each time, so therefore this becomes 6n. Now, let's find out what 6n actually is. 6 times 1 is 6. 6 times 2 is 12, 18, 24. Now, that's what we know, but it's not the same as the one above. Sometimes it is, but not this case. So 7 minus 6 is 1, 1, 1, 1. The difference between 6n and the sequence numbers is 1. Therefore, we have 6n plus 1 is our nth term expression. So if we want to find the 10th number in there, we do 6 times 10 plus 1. Oh, don't need that. Plus 1 equals 61. There, 61. Right, another example. Quite a few examples to get through. Let's have a look at some more we've got. Let's do these sequence numbers. So the n numbers are the numbers in the sequence are 1, 2, 3, 4. Only need to do 4 because we've got this off pat. Now let's do some numbers, and we're going to go 0, 5, so we'll go up in 5, 0, 5, 10, 15. Okay, the difference between all these is 5. So this becomes 5n. What is 5n? 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15, and 20. Now, always subtract the n numbers from the sequence numbers. So 0 minus 5 is minus 5. 5 minus 10 is minus 5. 10 minus 15 is minus, so it's minus 5 all the way along. So that's the bit we have to add to the end of the sequence to make the nth term. So this time we had a negative there. So 5n minus n. So if we want to find the 40th number, it would be 5 times 40 minus 5. So it's 200 minus 5, which equals 195, would go in here. Right, let's do this. The n number, 1, 2, 3, 4. The numbers in the sequence are going to be minus 6, minus 3, 0, and 3. So what's going on? We're adding 3 each time. So that becomes 3n. Now 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. And 3 times 4 is 12. Yeah. Now, minus 6 minus 3 is minus 9. minus 3 minus 6 is minus 9, 0 minus 9 is minus 9, so it's minus 9 all along with that, and our nth term is 3n minus 9. See, we've got another one for us, something a bit more tricky. Okay, let's do the n numbers. 1, 2, 3, 4. The numbers in the sequence are 10, 8, 6, 4. The difference between these is minus 2 because we're going down. So this becomes minus 2n. So minus 2 times 1 is minus 2. Minus 2 times 2 is minus 4. Minus 6 and minus 8. So 10 minus minus 2 is 12. 8 minus minus 4 is 12. So these are all 12. Okay. And we're adding 12. So it's minus 2n plus 12. You can swap this round because generally not a good idea to have a minus at the beginning of one of these. So 12 minus 2n. So let's try it out on, say, this one here. See if it works. So we've got 12 minus 2 times 3. 2 times 3 is 6. 12 minus 6 equals 6. And that is indeed our number in the sequence. Just one more of these linear sequences. So n and 1, 2, 3, 4, 3, 8, 13, and 18. Right, so what's the difference? It's 5, 5, 5. Therefore it's 5n. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15, and 5 times 4 is 20. 3 minus 5 is minus 2. 8 minus 10 is minus 2. 13, 15 minus 2. 18 minus 20 is minus 2. So therefore our term becomes 5n minus 2. So for linear arithmetic sequences, you will more likely have to work out the nth term, and they may ask you to work out what the sequence number is in a particular term. So for example, the 10th term. So we've got 5 times 10 minus 2, which equals 48. So that will be 48 when we get to that position. Okay, and that is the end of that.